Figure 4 shows a plan view of a sheep enclosure. The enclosure ABCDA, as shown in Figure 4, consists of a rectangle BCDE joined to an equilateral triangle BFA and a sector FEA of a circle with radius x and centre F. The points B, F and E lie on a straight line with FE equal to x metres and x is between 10 and 25. Find in metres squared the exact area of the sector FEA, giving your answer in terms of x in its simplest form. So I know that the area of a sector is a half r squared theta, as long as theta is in radians. So when I look at my sector here, first of all I can see that the radius is x. Then I just need to think about the angle. What's this angle here? I don't know at the moment, but I do know that this triangle is equilateral. It told me that in the question. Which means that the angles inside that triangle add up to pi radians. Remember that 180 degrees is pi radians. So therefore that angle there will be pi over 3 radians. So therefore, because we have a straight line here, the blue angle here will be 2 pi over 3 radians. And I know that because, like I say, we have a straight line, so that adds up to pi radians. And pi, take away pi over 3, is 2 pi over 3. So the angle of the sector there is 2 pi over 3. Just to simplify that then, we can see the 2's will cancel out and we will just get pi over 3 x squared. And that is the area of the sector in its simplest form. Right, let's move on to part B. We are told that the length BC is y, and y is greater than 0, and we've been told that the area of the enclosure is 1000. I need to show that y is equal to that expression. So the area will be the rectangle, the area of the rectangle, plus the triangle, plus the sector. So let's work out, well, we already know the sector. We just did that in the previous question. That's pi over 3 x squared. Let's work out the rectangle and the triangle now. Well, the rectangle, I can see that's got a height of y, and its width here, I know that that is 2x. I know it's 2x because I know that this length here is x, and because it's a sector, this length here has to be x as well. And then because that is an equilateral triangle, this length here has to be x as well. So that's where the 2x came from. So therefore, the area of that rectangle is 2xy. The width is 2x, the height is y, so the area is 2xy. Now for the triangle. Well, I know that the area of a triangle is a half AB sine C. It's an equilateral triangle, and I know that both of the lengths are x, and I know that the angle is pi over 3. So if we work that out, pi over 3 is the same thing as root. If you put that in your calculator, or you might remember off the top of your head, we get root 3 over 2. So that simplifies to be root 3 over 4 x squared. So that's the area of my triangle. Okay, so I have got an expression for my area in terms of x and y. All I want to do now is to rearrange, well, actually I'm told that the area was 1000. So I can make my expression equal to 1000. Now I am going to rearrange this to make y the subject and hopefully show it's the same thing as this. So first thing I'm going to do is I'm going to put all of the y's on, well, keep the y on one side and put anything that doesn't have a y on the other side. So I'm going to rewrite this as 2xy, and then I'm going to have the 1000 minus the root 3 over 4x squared minus the pi over 3x squared. So all I've done there is I've just taken both of these terms to the other side because they don't have a y in them. Next, right, let's divide everything through by 2. So that's me dividing everything through by 2. Now let me divide everything through by the x. So x squared divided by x is x, and x squared divided by x is x. I have now got y as the subject. I just need to make this look like this now. So just comparing, I've got the 500 over x at the front, that's good. I need to turn my second two terms into this. So first thing I'm going to do is get a common denominator. So I'm going to times this first fraction by 3 to make it 24. And I'm going to times the second fraction by 4 to make that 24. Now, because I have got a 1 over 24x here and a 1 over 24x here, in fact, actually, I've got a minus 1 over 24x in both of them. I can factorise that outside. So factorising the minus x over 24 outside, on the inside I'm left with 3 root 3 plus the 4 pi, which is what I needed to show. So that is part B of this question. Let's move to part C. Hence, show that the perimeter of the enclosure is given by this expression here. Right, let's look at the perimeter. So that's going to be this length, which I know is 2x, plus this length, which I know is y, plus this length here. Now that's the arc length. And I know the formula for arc length is r times theta. In this case, my r is x. And remember that the theta was 2 pi over 3. So that arc length then will be 2 over 3 pi x. Right, carrying on, the next part of the perimeter is this length here, which I know is x, because remember that's an equilateral triangle. And then the final part of the shape is that length there, which is y. So this is my expression for the perimeter of the enclosure. Let me simplify that a little bit, because I've got a 2x plus x is 3x, plus the 2/3 pi x, and then I've got 2y. Now, notice that I need to get my answer only in terms of x. I don't want this y here. But that's fine, because what I'm going to do is I'm going to take my answer from part B and substitute that in. So leave the first two terms alone, and then we've got two lots of 500 over x minus x over 24, 4 pi plus 3 root 3. Right, I now need to hopefully simplify that and make it look like this. So let's expand those brackets. So 2 lots of the 500 over x is 1000 over x. And then 2 lots of the minus x over 24. So timesing these together would be minus x over 12. And I'll leave that bracket there for now. Now, let me just compare what I've got here. The 1000 over x is good, but I need to group up all of my x terms. So let me expand those brackets so I can compare all of these x terms together. So actually I'm going to put the 1000 over x at the front. And then I've got the 2x, the 2 over 3 pi x, I've got the minus 4 pi x over 12, and I've got the minus 3 root 3x over 12. Right, I want these two terms to have a denominator of 12 so I can group them together. So I'm going to times this fraction by 4, and I'm going to times this fraction here by 12. So plus 24 next. Oh, sorry, I've just realised, I'm not going to re-record this, I've just realised I've made a mistake here. For some reason I turned that 3x into a 2x there. So I'm just going to go through, that should be a 3. 3, 3, 3. This should have been a 36. Right, let's carry on. So we can now, these are like terms. 8 pi x over 12 minus 4 pi x over 12 is 4 pi x over 12. Now, last step, we can see we've got an x over 12 here, an x over 12 here, and an x over 12 here. We can factorise that outside to get the answer that we wished for, which was 1000 over x plus x over 12 times 36 plus 4 pi minus 3 root 3. And there we go. That is part C of this question. Right, part D. By the way, you can still get all of these 7 marks even if you've got nothing else in this question right so far. So you can still get 7 out of 15 even if you've not got the first 8 marks. Part D says to use calculus to find the minimum value of P. So minimum, I'm thinking dP by dx is equal to 0. So let me rewrite P in a form where I can differentiate it. So I'm going to write that 1000 over x as being 1000 x to the power minus 1 plus the x over 12 4 pi plus 36 minus 3 root 3. Right, now we can differentiate this. So 1000x to the power minus 1, so multiplied by the minus 1, take 1 away from the power. And then this second term, well, notice that we just have a single x, and all of this is a constant. And so just differentiating x will just give the constant coefficient. Just like when you differentiate 2x, you'll get 2. When you differentiate 3x, you'll get 3. When you differentiate 10x, you'll get 10. When I differentiate 4 pi plus 36 minus 3 root 3 over 12x, I will get 4 pi plus 36 minus 3 root 3 over 12. And that has to equal 0 for a minimum point. So now we want to solve this equation to work out x. Now, a bit awkward at the moment with that minus 2 power. I don't like that being there when I solve equations. I like it for differentiation, but I don't like it for solving. So underneath here then, I'm going to rewrite this as minus 1000 over x squared right. I am now going to multiply through. Actually, I'm going to move this to the right hand side so it becomes a positive. Like this. I am now going to multiply both sides by the x squared. So I will get I will now divide both sides by all of this. So that's going to give me, so times in the 1000 by 12 will give 12,000 over the 4 pi plus 36 minus 3 root 3. That's all I've just done there. Took that 12, multiplied it by the 1000, and then divided by that. Square root, all of that. Right, get my calculator. 12,000 divided by 4 pi plus 36 minus 3 root 3. And we get 16.6339. So that is the value of x that makes the perimeter a minimum. It is not the minimum value of p. That's the minimum, that's the value of x that makes a minimum. That's what the x here is going to be that will make the perimeter of this shape a minimum. So what I need to do to actually work out the perimeter now is to take that and substitute it in to the original perimeter expression, either this expression here or this expression here. So let's do that then. So we're going to do it 1000 over the answer plus the answer over 12 times 4 pi plus 36 minus 3 root 3. So just bear with me while I type that into my calculator. 4 pi and we get that the minimum value of the perimeter to the nearest metre is 120 metres. And that is your answer to part D of the question. Finally, part E, justify by further differentiation that that's the value of P you found is a minimum rather than a maximum. So, I know that at a minimum, the second derivative is going to be positive. So at a minimum, d2p by dx squared is greater than 0. So that's what I need to show when x is 16.6. So let me just come back up to this point here where I had my first derivative. So I can differentiate that again to get my second derivative. So d2p by dx squared. So the minus 1000x to the power minus 2 will become a positive 2000x to the power minus 3. All of this here is just a constant. So when I differentiate that, it's just going to become 0. So actually this is just my second derivative. All I need to do now is to show that when I substitute the 16.6 in, I get something that's bigger than 0. So 2000 over 16.6 to the power 3, and clearly we can see that that is going to be a positive number. I will show just for completeness, we get 0.437, which is greater than 0, therefore a minimum. And there we go. We have finished that question.